Welcome to the podcast. Today we're exploring what zero carbon homes really means and why timber can play a central role in delivering them at scale in Wales. This conversation is based on research from the Homegrown Homes Project, which sets out a practical, evidence-based pathway to housing that genuinely meets our climate goals, not just on paper, but in real life. Let's start with the big picture. Why housing and why now?
It sounds like housing isn't just part of the problem, but potentially part of the solution. What makes homes such a critical place to focus our efforts?
The built environment is responsible for a significant share of carbon emissions, not just through energy use, but through materials and construction. That's why this report focuses on net zero whole life carbon, meaning all emissions from construction, operation, maintenance, and end of life are counted, then reduced and balanced. A key insight is that as homes become more energy efficient, the carbon locked into materials becomes increasingly important. Ignoring that would mean missing half the problem.
So reducing energy bills isn't enough on its own. If materials matter this much, how does design influence those emissions?
Design choices have a surprisingly large impact on carbon. The report shows that compact homes, like terraces rather than detached houses, lose less heat and require fewer materials per dwelling. This reduces both operational energy demand and embodied carbon. Using detailed energy modelling, the study demonstrates how orientation, layout, and form factor directly affect heating demand, sometimes more than technology choices like heat pumps or solar panels.
That suggests carbon emissions are built into the process long before construction starts. But where does timber come into all of this?
Timber is critical because it does two jobs at once. First, it replaces high-carbon materials like steel and concrete. Second, it stores carbon absorbed by trees during growth, locking it into buildings for decades. The report shows that advanced timber construction systems can dramatically cut upfront carbon while still delivering high performance. Timber also works exceptionally well with off-site manufacturing, improving build quality and consistency.
If timber offers all these benefits, what's stopping us from delivering zero carbon homes at scale already?
One major barrier is the energy performance gap, the difference between how buildings are designed to perform and how they actually perform once people move in. Poor detailing, inconsistent construction quality, and weak monitoring can all undermine carbon targets. The report argues that robust quality assurance, performance monitoring, and proven standards like the passive house approach are essential if zero carbon homes are to work in reality.
That raises a big question. Once we've reduced emissions as far as possible, how do we deal with what's left?
Offsetting is treated very carefully in this study. It's presented as a last step, not a shortcut. After reducing emissions through design, materials, and performance, remaining carbon can be balanced through verified woodland creation. Crucially, the report shows this can be done at relatively low cost while creating long-term environmental assets. The message is clear. Zero carbon homes are achievable today, but only with a whole system approach.
So this isn't a future concept. It's a roadmap we could start following right now?
Exactly. This report isn't just about theory, it's about giving designers, housing providers, and policymakers the tools to act now. If you're interested in sustainable construction, climate policy, or the future of housing, reading the full report is well worth your time.